So let's now look at the programming languages, which is another tool for writing a software. So the first thing we should concentrate on is known as machine language. So as we all know, the computer understands only two things: bits, zeros and ones. So that means electricity, the presence of electricity or not. So actually whatever we use, everything gets translated into zeros and ones, which is known as machine language. So this is the computer's native language, and it differs among different types of computers based on the processor make. That means whether the processor is from Intel or AMD or some other company. If the operating system or the processor is a 32 base system or 64 base system. So based on the different systems, every system has its unique machine language, which is a set of built-in primitive instructions in the form of binary code. That means it consists of only zeros and ones. For example, to add two numbers, the instruction in binary code could be like this. So all the zeros and ones. So you can imagine how difficult it would be if we were supposed to write with zeros and ones to do every single work that we now do with a computer. So which is very difficult to read and definitely even more difficult to modify. Then we had assembly language. Okay, so this is before even my birth. So what is an assembly language? So when the programmers were finding it very difficult to code with zeros and ones, and even more difficult to fix any bugs, they came up with a different solution. This is known as assembly language. So what they did was they used short descriptive word, which is known as mnemonic, to represent each of the machine language instructions. So let's say with this instruction, maybe the first 3 bits, maybe the first 8 bits, these are the instructions. That means add, subtract, or multiply, or store. So these are the instructions, and the remaining bits are the data. So in assembly language, instead of zeros and ones, there are words, descriptive words like add, ADD, add. This means 11011. Sub means some other code. So in assembly language, they maintained a table where in one column they would write the words that we human would understand, and in the other column they would write this zeros and ones code for each of those commands. So for example, to add the two numbers 2 and 3 and get the result, an instruction in assembly code would be like this, like add 2 comma 3 comma result. So another program which will just look up at the table for the code of add, then replace add with the particular zeros and ones, convert 2 into binary, convert 3 into binary, and convert the result of this result register into binary, and finally we would get the same code with zeros and ones. So this program is known as assembler, which is used to translate the assembly language program into machine code. So what they would do is, just as I have said, we human would write it like this. Then the program assembler would take this part, look up at the table, and convert this part into zeros and ones. So an instruction such as this in assembly language corresponds to one instruction in the machine code. So in terms of programming, programming number of lines, or programming, in terms of programming, there are no difference, but using words instead of the zeros and ones actually made the life of programmers a lot easier. So writing in assembly requires one to know how the CPU works. So when you will do courses like CSE 332, you will likely get to know about these things more. Okay, so since assembly language also depends on the architecture of the hardware, one has to have the knowledge of how the CPU of that particular machine works. So this is also referred to as low level language, which is very close to hardware language, and this is machine dependent. So if you change the machine, the codes will change as well. So that was also a problem, because for every machine we would have to write different codes to get the same output. That's why then the programmers or the software engineers or the computer scientists came up with a new type of language, which is known as high level language. So this is the first thing, is it's platform independent. That means the language of the language itself does not depend on the hardware of the company the hardware that made the hardware, or how many bits it's required as the instruction said. It doesn't depend on that, which is more like English, so mostly like natural language. That's why it's easy to learn and use. You may feel that programming for you is difficult, but believe me, this is the most simple thing. So a program written in high level language, this is called a source program or source code. And definitely a source program or source code is similar to a poem we write. Okay, a computer cannot directly use a high level use a program written in high level language. So a source program must be translated into machine code for execution. So before we want to execute it, that program needs to be translated into machine code. So there are two types of translators. One is known as interpreter, the other is known as compiler. So there's difference in how these two things work. So it's not that one is better than the other, but it's more like it depends on the use and application. So what does interpreter do? It reads one statement from the source code, translate that particular statement, run the code, and then executes it. Okay, so what it does everything line by line. Okay, so every time we need to run a particular program, the interpreter absolutely every time do this same cycle over and over again. On the other hand, a compiler translates the entire source code into a machine code file and then save the machine code file. Later on, when it wants to execute, it doesn't require to translate that again, rather it just executes the machine code file. Okay, so next we look at the operating system, which actually controls the computer's activities. The major tasks include controlling and monitoring system activities, allocating and assigning system resources, and the scheduling operations. So there are three types of schedulers: multi-programming, multi-threading, and multiprocessing. So a multi-programming allows multiple programs to run simultaneously by sharing the same CPU. So example is when you use a word processor, you are actually editing a file, and at the same time your web browser is downloading a file using the same CPU. Then we have multi-threading, where a single program is executed multiple tasks at the same time. So the task is not dependent on each other, so they can run actually in parallel at the same time. So example, a word processing program allows users to simultaneously edit text and save it to a disk. And finally, multiprocessing, where two or more processors together perform subtasks concurrently and then combine solutions of the subtask to obtain solution for the entire task. So this is again when there are parallel tasks which doesn't depend on each other. We can actually divide them into into several processors, and that can be done concurrently. So next we will move into the introduction to Java, and we will see the features of Java and why we are concentrating or we will be covering Java in this course. Thank you.